Question 1. From a practical standpoint, if Mr. Alvarez is assessing a high-performance office building in Phoenix, which includes a mix of open-plan areas, enclosed offices, and a data center, or should be his first step in determining the cooling load, especially given that most zones are exposed to significant solar gain and internal loads. A. Use square footage-based rules of thumb to estimate total load. B. Perform a detailed manual J calculation based on residential assumptions. C. Conduct a comprehensive manual N or ASHRAE-based load analysis considering occupancy, solar gain, and equipment. D. Select equipment based on historical usage patterns of similar buildings. Answer. Correct answer. C. Explanation. Manual N for commercial buildings or ASHRAE methods provide the most accurate load estimation, taking into account solar heat gain, internal equipment loads, people density, and ventilation needs. Rule of thumb and historical comparisons risk under oversizing systems. Residential methods like manual J are inappropriate for commercial applications. An ASHRAE Handbook Fundamentals outlines this approach. Question 2. Considering the evidence, what happens to the air's enthalpy and relative humidity when air at 75 degrees dry bulb and 50% RH passes over cooling coil and exits at 55 degrees saturated? A. Enthalpy increases and RH increases. B. Enthalpy decreases and RH decreases. C. Enthalpy decreases and RH increases. D. Enthalpy remains constant and RH decreases. Answer. Correct answer. C. Explanation. When air is cooled and dehumidified, the enthalpy, total heat content, decreases due to the removal of both sensible and latent heat. However, the relative humidity increases because cooler air can hold less moisture and its saturation, RH, reaches 100%. The psychrometric chart clearly shows this relationship. Refer to ASHRAE psychrometric fundamentals. Question 3. Under the assumption that a hospital HVAC system must balance energy efficiency with precise environmental control, what is the best control strategy for the operating rooms? A. Programmable thermostats with time-based schedules. B. Standalone thermostats with manual override. C. A building automation system with PID control, pressure monitoring, and alarms. D. VAP boxes with constant volume supply fans. Answer. Correct answer. C. Explanation. Operating rooms demand precise temperature, pressure, positive, and humidity control. A BAS with PID loops, zone sensors, and alarms ensures environmental integrity and patient safety. Time-based or manual controls don't meet critical requirements. The ASHRAE Standard 170 ventilation of healthcare facilities and ASH guidelines support this approach. Question 4. Through careful analysis of a low-profile commercial building retrofit, Mr. Langston must upgrade an existing duct system to meet current ventilation needs. What challenge must he prioritize when resizing ducts in the constrained ceiling plenum? A. Use the smallest diameter duct to maximize air velocity. B. Increase duct length to reduce pressure drop. C. Maintain proper duct aspect ratio to minimize friction losses. D. Ignore duct insulation as long as airflow is sufficient. Answer. Correct answer. C. Explanation. In tight plenums, maintaining a duct aspect ratio close to 1 or 2. 1 helps reduce friction and pressure losses. Smaller ducts increase velocity and noise, while longer ducts raise static pressure. Insulation is also required per code, but isn't the first challenge. Refer to SMACNA and ASHRAE guidelines on duct design. Question 5. When evaluating the merits of a school's HVAC performance, Mr. Daniels identifies elevated co-levels in classrooms despite functioning ventilation fans. Which underlying issue is most likely? A. The air filters are clogged. B. The ventilation rate is below ASHRAE 62.1 standards for occupancy. C. The duct static pressure is too high. D. The outside air dampers are fully closed during operation. Answer. Correct answer. B. Explanation. High CO indicates inadequate fresh air per occupant. Even if fans run, underventilation can occur due to incorrect outside air damper positions, control strategy, or miscalculated design. Ventilation rates ASHRAE 62.1 sets minimum ventilation per person and per area for different space types, making B the most likely root cause. Question 6. To illustrate this point, which application would benefit most from a centrifugal compressor rather than a scroll or reciprocating compressor, a 2-ton residential split AC system, B a 5-ton rooftop unit for a restaurant, C a 500-ton water-cooled chiller serving a high-rise, D a variable speed mini split in a server room? Answer. Correct answer, C. Explanation. Centrifugal compressors are best suited for high-capacity systems due to their efficiency at large volumes and relatively low pressure ratios. Scroll and reciprocating compressors dominate small to medium systems. Mini-splits use inverter-driven scrolls or rotary types. ARIAN ASHRAE Handbook supports centrifugal use for 100-plus ton applications. Question 7. In response to client concerns, Ortega is reviewing HVAC design changes post-construction. What is the best practice to ensure changes are clearly documented for legal and operational purposes? A. Email all revisions to the client and contractor. B. Issue a verbal directive during the job site meeting. C. Update and issue a formal as-built drawing with changelog. D. Make note in her personal project diary. Answer. Correct answer, C. Explanation. Formal as-built documents with a revision history ensure all stakeholders have an official, traceable record of system changes. This supports future maintenance, warranty, and legal review. Verbal or informal notes lack enforceability. See our contract documents and general construction law practices for documentation standards. Question 8. By evaluating system behavior, what could be the cause if the superheat is abnormally high and the suction pressure is low in a commercial refrigeration system? A. Oversized expansion valve. B. Undercharge of refrigerant or restricted metering device. C. Flooded evaporator. D. Short cycling of the compressor. Answer. Correct answer, B. Explanation. High superheat and low suction pressure typically point to insufficient refrigerant flow, either from an undercharged system or restriction before the evaporator. This reduces evaporator efficiency. Flooded evaporator would cause low superheat, not high. Refer to the RSA's troubleshooting procedures and HVACR cycle diagnostics. Question 9. In light of recent developments in energy efficiency codes, what is the primary benefit of installing an energy recovery ventilator in a commercial building located in a humid climate? A. Increasing heating capacity. B. Controlling carbon monoxide. C. Reducing the cooling load by preconditioning outside air. D. Filtering airborne bacteria. Answer. Correct answer, C. Explanation. Nerves transfer both heat and moisture between the exhaust and incoming air streams, effectively reducing the HVAC system's latent and sensible load. This is especially beneficial in humid climates, improving IAC energy efficiency. ASHRAE 90.1 and 62.1 recognize nerves as a strategy to meet ventilation and energy standards. Question 10. From a historical standpoint, Mr. Bennett, an HVAC consultant, is asked by a contractor to approve substandard equipment to meet a project deadline. Weighs his professional obligation. A. Approve the equipment under protest. B. Inform the client and document the concern. C. Ignore the issue unless a problem occurs. D. Accept the request if it saves the client money. Answer. Correct answer, B. Explanation. HVAC consultants must adhere to ethical standards prioritizing public safety, honesty, and code compliance. Proving substandard work compromises system performance and legal standing. ASHRAE Code of Ethics and state licensure laws mandate that professionals act with integrity, notify clients of issues, and document potential risks. Question 11. In the context of designing a chilled water system for a new biotech lab with 24/7 equipment operation, Reynolds is tasked with selecting a chiller. After running accurate load calculations, she finds the peak cooling load is 180 tons and the minimum part load demand is 30 tons. What should she prioritize when selecting the chiller to optimize both efficiency and capacity control? A. Choose a chiller with multiple compressors and VVFDS for staging. B. Size A single fixed-speed chiller at 200 tons to avoid undersizing. C. Install two identical chillers, each at 180 tons for redundancy. D. Select a centrifugal chiller for its low startup power. Answer. Correct answer. A. Explanation. Multiple compressors with variable frequency drives allow precise modulation across a wide range of loads, maintaining part load efficiency. Crucial for 24/7 labs. Oversizing wastes energy and risks short cycling. Centrifugal chillers are efficient at high capacities but perform poorly at low part loads with VFDS. See ASHRAE 90.1 and HVAC System Design Handbook. Question 12. Throughout the course of a hydronic system commissioning, Istacata notices that chilled water is not reaching the farthest air handler. Static pressure is within design limits. What is the most likely root cause? A. The differential pressure bypass valve is set too low. B. The system is airbound due to improper venting. C. The chiller has undercharged with refrigerant. D. The primary pump is oversized for system flow. Answer. Correct answer. B. Explanation. Air trapped in the piping restricts flow to terminal units, especially at high points or distant coils. Despite normal static pressure, an airbound system cannot circulate properly. Refrigerant charge is unrelated in hydronic systems. Oversized pumps can cause noise and erosion, but wouldn't prevent flow alone. Refer to ASHRAE Handbook. HVAC Systems and Equipment. Question 13. The correlation between plate heat exchangers and shell and tube designs is often misunderstood in HVAC applications. Which of the following best explains why a plate heat exchanger might be chosen over a shell and tube design in a hospital central plant? A. Plate heat exchangers require less maintenance than shell and tube units. B. Shell and tube designs have superior heat transfer coefficients. C. Plate exchangers provide higher efficiency in a more compact footprint. D. Shell and tube units are more efficient at part load operation. Answer. Correct answer. C. Explanation. Plate heat exchangers offer superior thermal performance per square foot due to turbulent flow and large surface area. They are also space efficient, which is critical in retrofit or constrained applications. Shell and tube designs are more durable but less efficient in compact spaces. Maintenance depends on fouling tendencies. ASHRAE Fundamentals supports this selection logic. Question 14. The prevailing attitude toward high-efficiency filtration systems is that they significantly reduce indoor contaminants. However, Mr. Patel notices airflow complaints after upgrading to MERV 13 filters. What is the most probable cause? A. Increased filter surface area caused fan imbalance. B. The ductwork is undersized for the static pressure rise. C. The filters were installed in reverse. D. The outside air damper failed in the closed position. Answer. Correct answer. B. Explanation. High MERV ratings increase resistance to airflow, especially if the system wasn't designed for the added pressure drop. Undersized ducts or insufficient fan capacity can cause airflow and comfort issues. While reverse installation can reduce effectiveness, the pressure drop is still the primary issue. See ASHRAE 52.2 for filter pressure performance. Question 15. Examining the consequences of a water source heat pump system not meeting heating demand is Novak inspects the loop temperature and finds it significantly lower than expected. Which issue most likely explains this? A. The heat pump compressors are oversized. B. The building control system is in cooling mode. C. The loop heat exchanger is fouled or undersized. D. The water pumps are operating above design flow. Answer. Correct answer. C. Explanation. A fouled or undersized heat exchanger can't efficiently reject or absorb heat, leading to low loop temperatures and poor performance. Oversized compressors and control motors may contribute but wouldn't specifically reduce loop temperature. High pump flow may increase energy use but not cause inadequate heating. Refer to ASHRAE HVAC Applications Handbook. Question 16. As a result of a client's goal to pursue LEED certification, ISWANG is asked to integrate a renewable system into the HVAC design. The building is located in a temperate climate with stable ground temperatures year-round. Which solution provides the best balance of renewable integration and HVAC efficiency? A. Solar thermal collectors with absorption chillers. B. Photovoltaic panels powering conventional air-cooled DX systems. C. Ground source heat pump system using vertical wells. D. Biomass boilers coupled with high-efficiency condensing units. Answer. Correct answer. C. Explanation. Ground source geothermal heat pumps are highly efficient and leverage the stable underground temperature as a renewable heat sink source. Vertical wells are ideal in limited land areas and maximize efficiency. PV systems help offset electrical use but don't improve HVACR. Lead recognizes geothermal under EEC and other credits. See as Lead VV guidelines. Question 17. The question remains whether Trend should recommend natural ventilation as a strategy to meet HRC 62.1 ventilation rates in a mixed-use building. What factor most critically determines if natural ventilation can meet code? A. Whether operable windows are present in every space. B. Whether airflow through openings can be measured and verified. C. Whether the building has any mechanical ventilation system installed. D. Whether the building is occupied more than 8 hours per day. Answer. Correct answer. B. Explanation. HRC 62.1 allows natural ventilation but requires documented airflow performance, often needing modeling or on-site measurements. Operable windows alone aren't sufficient. Mixed mode strategies are common but must comply with code-required air exchange. See HRC 62.1, 2022, Section 6.4 and 6.5 for verification criteria. Question 18. From multiple perspectives, HRConquer evaluates an existing high-rise and finds elevated energy usage during unoccupied periods. What control strategy would most effectively reduce off-hour HVAC energy waste? A. Manual overrides on each floor for tenant control. B. Setback temperature schedules using programmable thermostats. C. Installation of occupancy sensors and zone-based BAS. D. Adding variable air volume VAV terminal units. Answer. Correct answer. C. Explanation. Occupancy sensors integrated into a BAS allow for dynamic HVAC control, adjusting airflow, temperature, and ventilation based on actual usage, dramatically reducing energy waste. Setbacks are less adaptive. VAV terminals help zone control but don't address occupancy. See HRC 90.1 and Energy Star commercial audit recommendations. Question 19. Historically speaking, Mr. Douglas is reviewing a constant speed pump system in a university. The chilled water loop suffers from poor delta T and high return temperatures. What is the likely reason for the inefficiency? A. The system is balanced too aggressively. B. Control valves are hunting at part load conditions. C. The pump is oversized, causing excess flow and low heat transfer. D. The air separator is located at the highest point in the system. Answer. Correct answer. C. Explanation. Oversized pumps push too much flow, reducing temperature difference across coils, low delta T. This causes inefficiency and poor heat exchange. Low delta T syndrome is well documented in HRC literature. Control valve hunting may cause instability, but not necessarily low delta T. See HRC HVAC systems and equipment chapter on pumping. Question 20. The foundation of consulting integrity lies in managing liability effectively. ISTA Singh is hired to review and sign off on HVAC plans completed by another engineer. The client offers a bonus for rapid approval. What is the most ethical and risk-averse course of action? A. Accept and sign the drawings if the design looks standard. B. Review only the sections related to HVAC loads and airflow. C. Perform a full technical review and document all findings before signing. D. Refuse the project outright to avoid any liability. Answer. Correct answer. C. Explanation. Consultants who sign off on drawings assume professional liability and ethical responsibility. Full technical due diligence is required to protect both the client and the engineer. HRC's Code of Ethics and most engineering licensure boards require competent review before sealing any work. Failure to do so may result in disciplinary action. Question 21. Taking into account the moisture problems reported in a coastal condominium project, is Simmons, a consulting HVACR professional, is asked to investigate mold growth behind drywall near the ceiling. The building uses packaged rooftop units and has no dedicated dehumidification. What building envelope flaw is most likely causing this issue? A. Inadequate roof insulation. B. Air leakage allowing humid outside air into wall cavities. C. Oversized HVAC systems. D. Lowy glass on windows reducing solar heat gain. Answer. Correct answer. B. Explanation. Air leakage allows humid outdoor air to infiltrate wall cavities where it condenses on cooler surfaces, fostering mold. This is especially problematic in humid climates with negatively pressurized interiors. ASHRAE 160 recommends air barrier systems and dew point analysis. HVAC oversizing can worsen humidity control, but infiltration is the primary cause in this case. Question 22. To what degree does retrocommissioning improve HVAC efficiency in an older commercial facility? Mr. Whittaker is evaluating a 15-year-old office building. What is typically the most cost-effective outcome of retrocommissioning HVAC systems? A. Replacing all ductwork with larger diameter systems. B. Upgrading chillers to magnetic bearing centrifugal units. C. Identifying and correcting control system sequence issues. D. Installing rooftop photovoltaic systems. Answer. Correct answer. C. Explanation. Retrocommissioning often uncovers misconfigured control sequences, like simultaneous heating and cooling or uncoordinated valve box schedules. That can be fixed with minimal capital investment and high returns. While chiller upgrades or PV systems may provide benefits, control corrections yield fast and significant savings. Refer to ASHRAE Guideline 0.2 and seek save best practices. Question 23. In comparison with traditional VAV systems, when should a variable refrigerant flow VRF system be avoided? Mr. Bell is designing HVAC for a small manufacturing plant with high outside air requirements and dirty conditions. A. When interior zones have differing thermal loads. B. When zoning flexibility and part load efficiency are desired. C. When extensive filtration and outside air treatment is necessary. D. When roof space is limited for condensing units. Answer. Correct answer. C. Explanation. ERF systems recirculate indoor air and aren't ideal when large amounts of outside air must be treated or where filtration of dirty air is crucial. They are highly efficient in clean, multi-zone environments with low ventilation loads. ASHRAE 90.1 acknowledges VRF efficiency but warns against their use in high ventilation industrial settings. Question 24. The impact of life cycle cost analysis (LCCA) is often misunderstood. Mr. Ramish is comparing two HVAC systems. One has low first cost but higher operating cost, while the other has a higher initial cost but much lower energy use. What does LCCA reveal about making the best decision? A. It only considers first cost and payback period. B. It prioritizes annual maintenance costs above all. C. It evaluates total cost of ownership, including energy, maintenance, and salvage. D. It ignores utility incentives and depreciation benefits. Answer. Correct answer. C. Explanation. Life cycle cost analysis evaluates total cost of ownership over a defined period, factoring in capital, energy, maintenance, replacement, and residual value. This is the preferred method per Federal Energy Management Program (FEMP) guidelines and ASHRAE recommendations. It supports long-term financial decisions beyond simple payback. Question 25. Despite the fact that the HVAC system in a new elementary school is operating as designed, co-levels remain persistently elevated in classrooms. What underlying issue is most likely the cause? A. The mechanical ventilation rate is lower than required. B. The building envelope is too tight. C. The heating system is oversized. D. The outdoor air intake damper is installed on the return side. Answer. Correct answer. A. Explanation. Elevated CO usually results from insufficient outdoor air ventilation relative to occupancy. This often happens when ventilation rates don't meet ASHRAE standard 62.1 or if economizers and dampers aren't operating properly. Tight envelopes reduce infiltration, but that's generally beneficial when paired with proper ventilation. Oversized heating has no effect on comfort. Question 26. A critical examination of a hotel HVAC system reveals guest complaints about lack of temperature control despite functioning units. Is Dupree notes that a central BAS is in place, but guest room units have local thermostats. What's the likely cause of the issue? A. The BAS is improperly overriding guest controls. B. The central chiller is undersized. C. The fan coils are lacking balancing valves. D. Local thermostats are not wired to actuators. Answer. Correct answer. A. Explanation. A BAS overriding local control, especially in poorly integrated systems, can create conflicting inputs, leaving thermostats ineffective. In hotels, comfort is paramount and BAS configurations must respect local control zones. See BACnet integration standards and ASHRAE 135 for guidance on control, conflicts and network systems. Question 27. With the advent of performance-based lead credits, ISTA-TRAN is evaluating HVAC strategies for a commercial mixed-use project seeking LEED goal. Which of the following HVAC approaches contributes to multiple LEED categories: energy and atmosphere, HVAC, and innovation? A. Installing standard VAV systems with economizers. B. Using energy recovery ventilators and demand control ventilation. C. Relying solely on natural ventilation in common areas. D. Integrating rooftop DX units with programmable thermostats. Answer. Correct answer. B. Explanation. ERVs reduce energy load while improving HVAC by conditioning incoming outdoor air. Demand control ventilation saves energy by reducing overventilation. These features support multiple LEED categories, including energy optimization, enhanced HVAC, and innovation in design. LEED V and V.1 reference these technologies as compliance pathways. Question 20. By comparing airflow and temperature data, ISTA Doyle notes that a VAV system supply air temperature is stable, but zone temperatures fluctuate wildly, or performance issue is most likely at play. A. Excessive outside air ventilation. B. Inadequate static pressure in the supply duct. C. Malfunctioning VAV box control or actuator failure. D. Improper economizer operation. Answer. Correct answer. C. Explanation. Fluctuating zone temperatures despite stable supply air suggest a control or actuator failure at the VAV box level. Likely the damper isn't modulating as required. Static pressure issues usually affect all zones. CNEB guidelines on air distribution troubleshooting and ASHRAE commissioning protocols for controls. Question 29. The underlying principle of ADO refrigerant adoption involves not just environmental impact, but also performance and safety. ISCO is specifying equipment for a data center with compact mechanical rooms. Which factor is most critical when selecting ADO refrigerant in this case? A. Toxicity and flammability under ASHRAE 34 safety group classifications. B. Compressor horsepower ratings. C. Refrigerant oil type. D. Discharge line pressure drop. Answer. Correct answer. A. Explanation. In confined spaces like data centers, refrigerant safety classification is critical. ASHRAE 34 defines toxicity or B and flammability. 1.3. Many DIDU refrigerants fall into mildly flammable AL categories, requiring ventilation and leak detection. Performance parameters are also important, but secondary to occupant and facility safety. Question 30. The most significant aspect of selecting a chiller for a high-rise residential building with space constraints is the trade-off between acoustic performance, efficiency, and footprint. ISTA Escobar is evaluating water-cooled versus air-cooled options. Which factor makes water-cooled chillers preferable despite more complex installation? A. Lower initial cost and reduced maintenance. B. Superior energy efficiency and quieter operation. C. Smaller refrigerant charge and simpler controls. D. Better performance during ambient heat waves. Answer. Correct answer. B. Explanation. Water-cooled chillers are more efficient and quieter, making them ideal for noise-sensitive and space-limited environments. Although installation is more complex, their operational benefits often justify the investment. Air-cooled units are easier to install but noisier and less efficient. ASHRAE 90.1 and green building programs often favor water-cooled systems for high performance.